I apologize for being a few minutes late today. I was finishing up my lunch and watching a couple of things grind away, but everything's going good right now. And this week is turning out to be a pretty fun week. So let's get started, I guess. Yesterday, what we had done was downloaded a bunch of OpenStreetMap data for the city of Peru. All of the Peru, Lima, Peru. I'm sorry, not the city of Peru, the city of Lima, Peru. Um, and we had started trying to get the data into the graph format for the finding directions problem. And where we sort of got stuck was either do we implement it ourselves and try to use some like XML serialization stuff. And then I was like, oh, wait, hold on. There's probably a library for this. And it turns out there was. So I went and I grabbed that library. And give me just a second here and I will find that library and share it with everybody so that we can all see that we're on the same page here. It's called OSM Sharp. OSM Sharp, and you can see I've been there quite a few times today. Let's make this bigger. There we go. Doop, doop. Okay, and basically, yeah, it was just this tool. It came with a bunch of samples, and then the samples weren't really that great. So what I ended up doing was going to the repository, and in the repository, what we have is you can just go to source, and it turns out that it was like really, really simple. There's just a few things away, a relation, and a node, which is exactly what I was trying to get out. So we were able to get, what we were hoping for. And as soon as I got it, now it's going through and actually doing the process of extracting it. So the second part to that is you have to go to the open street map key wiki. All right, and then you go to the OpenStreetMap wiki that shows you what the format looks like. Again, let's zoom in so we can all see it. And in here you see that there's just like, the wrapper, and then there's this bounds, and then there's a bunch of nodes, and nodes can come with tags, and then there's a bunch of ways, and ways can also come with tags. And these tags and the ways are, well, I guess also there's relations, and relations can also come with tags. To give you a sort of like general idea about what it is that each of these things is for, bounds is the actual bounds, like the geographical bounding box for all of the data that's inside of here. And then you have the node. A node represents a latitude, longitude point, just period. And that's all it represents. There can be a bunch of information about it in the form of tags. These things tell you like, oh, this is just a single item thing that we care about. Or I'm not 100% sure what the other tags are. We can go check that. And then you have ways. Ways are groups of node references. And so what this says is this way right here points back to all of these, some subset of these nodes that are also in this file, and organizes them into some sort of grouping. And one particular grouping is a street. Then you also have relations. Relations are like higher level sorts of ideas that can contain both nodes and ways, and also other relations inside of them. And the idea for this is something a little bit beyond what I think we're looking for what we're doing. Like this is a bus route, and I don't think you particularly need that. I think the way that it works is, it's built up of a couple of ways and maybe some not traffic sign, but like a bus stop pointer and whatnot. So there's a few things that sort of fit into there. But what we're doing right now is we're just trying to pull out the ways, and in particular, we're looking for things that have tags of highway. This highway tag, there should be like an element thing. Excuse me. Elements. And then highway. right here. And this tells you all about the highways, and the ones that we care about are basically all these ones at the top, which are, you know, motorway, trunk, primary, secondary, tertiary. Unclassified is apparently not, doesn't mean unknown. It just is like some historical thing. Residential streets, so like really small streets, and then service streets, which I'm not entirely sure what they are, but they're something. Maybe, you know, alleyways and whatnot. Then you also have these other highway things called motorway link, trunk link, primary link, secondary link, tertiary link, which is basically like on ramps when you run into an intersection or to, like, you know, major roads that have some connecting road, instead of it just being like a stoplight and boom, there's a stoplight. So what we're doing right now is we're loading up. We determined all of the ones that we want to collect. And then what we're doing is we're creating nodes, a list of nodes that we can refer back to so we don't end up generating the same state more than one time. And then we're also collecting a bunch of edges that we are going to use to build the graph, which are going to be the ways. Not directly the ways. The ways can contain multiple nodes, but they contain them in order. So we can say like, okay, here's the first one, here's the second one, here's the third one, and add a bunch of edges for each way, essentially. And that's sort of what we're going for. There's some other stuff on there about, like, you know, one-way streets and whatnot. For the time being, we're not really going to worry about that. We're just going to assume that all of these ways go forwards and backwards. So each, you know, you don't have different ideas for different sides of the road. It's just a giant road. And that's sort of the approach we're taking here. But anyway, yeah, so, and we're not going to care about relations for the time being. This is something we can update later, but really all I want to do is get like a very large map. And then I want to start plotting this on a Google map by the end of the day. And like, that's really the goal. Okay. So let's see here. We've got OSM geotype way, and if there is at least 2 nodes, then we have at least one edge. So what we want is I guess not from to, I guess we don't even need this really. What we want to say is I-1, say A, var B, and then what we want to do is create 2 edges, and what we need to do is calculate a distance between them. So the way that we're going to do this is, I'm pretty sure in this map data they don't have like long stretches of things. We're not going to get the exact length of distance between these 2 things, but what we're going to do is take an estimate of the length and give that a shot. So I think the way that we're going to do that is I was implementing something called the Haversine distance, and that's what we're going to use to determine the distance. So given any 2 lat-lon pairs, what we can do is calculate the distance between them on the surface of a sphere, effectively. All right, so what we want to say is var distance equals distance helper dot Haversine, and we want to pass it in a dot latitude, a dot longitude, b dot latitude, b dot longitude. Okay, and then we want to create 2 edges, 1 in each direction. I just got stuff going on today. All right. Edges. Let's see. Do 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 do. Edges. Let's see. Edges dot add new adjacency. What are the edges? We need an edge type. Okay. Let's go private class. OSM edge. And this is weighted graph edge of finding directions problem double. And then what we want to do is essentially implement that interface from to. Let's say get set let's do private. Private set and a weight of get private set. Why is this giving me crap? Cannot be used. Oh, that's right. Cannot be used as type parameter t node in the generic. Oh, I didn't want the problem. I want the state. Silly. Okay. Now what we want to say is edges.add OSM edge, and this is going to be 2 equals A from equals A, 2 equals B, and distance. We're gonna have to create one of these, huh? Sure. Public OSM edge of finding direction state from finding direction state to double weight. This dot from equals from. This dot to equals to. This dot weight equals weight. If I could learn how to type. A, B, distance. And then I want a second one that goes the other direction. B to A. All right, so again, this is us just determining that, or deciding that all of the edges, all of the roadways in this world are going to be bidirectional, and we'll worry about the unidirectional part of it later. Check if one to do make this work for one-way streets. Okay, perfect. Okay, so now what we've done is gotten the distance between these two, created the nodes. Well, we're sort of assuming that the nodes would already be in there, which I guess we'll know as soon as we run this the first time. But the way that all of the examples look, it has all of the nodes up at the top of the file. I'm not sure if that's entirely necessary for it to be a valid file or not, but that's the way we're going to go about it. And then the distance we have here is the haversine distance. And then we have two edges, one going in each direction for each of the things that we care about. This is great. I think this is going to return the whole map here. I sort of want to I sort of want to just run this and see how big it is, and kind of go from there. That's sort of my plan here. All right, let's get the to-do list out because there's one big to-do. Okay, well, we got this done. What was yesterday? 2/13. Also, happy Valentine's Day, everybody. 2019 02 02 13. And then what I want to do here is say check. No, what was I just doing? Finding directions, OpenStreetMap data helper. I want to say, oh yeah, make this work for, okay. Make the OSM graph extraction work for one-way streets. Yeah, definitely want to do that. Okay, so now that we have this, let's see what happens if we pull a graph. Also, what I want to do is get rid of the hard-coded path for data sets from everywhere that uses it. Currently in test. In OSM test. OSM tests. Okay. Now, let's go. Let's go load this up. That's what I want to do. Okay, let's add a new one here. Only this one is going to be test build graph of Lima, Peru. This is the file name, and then what we want is dot extract map graph Lima. Okay, now this is going to return. All right, so now what I want to do is sort of look at this map. That's what I want to do. You know what's interesting is I don't have any way of just grabbing the nodes out of the map. That's another thing I'll put on the to-do list. Find a way to grab the nodes out of the map so we can start blank. Okay. How are we going to do that for now then? I guess we could just pause it and reflect it. That's what we're going to do. Let's just take a little break right here. Int I equals 3. And then let's debug this test, and when we get to here, we're just going to take a look at what's in Lima, because I am actually super interested about this to see if we actually pulled everything. Or we could just walk through it. Let's try that. Hello and welcome to the stream. What I am working on at the moment is extracting a bunch of OpenStreetMap data into a graph so that we can do some searching on this giant, huge graph. Let's go in. Go in. Okay. Ooh, let's see here. kind of want to see what this is. I have no idea how many of these things there are. And I don't have a way to stop. You know what? Just run. See how long this takes. How big is this file? Oh, there we go. Whoa, goodness me. Look at that. The nodes, there are 1.3 million nodes. And of the streets, we got 870,000 street segments. Man, that's awesome. Let's from and to. I'm really curious now. Let's just pop this on a map. I want to see if this actually is a legit street segment. Maps.google.com, and what we're looking for is this. Can I copy that? Go back to the map. Let's go to, and then this is minus 77. 77042 6099. I want a point there. Are we in Peru? This has to be Peru, right? Ooh, yeah. What's up? Is this Peru? Yeah, Peru. Okay, 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 okay. I really want a point. Can I drop a marker at this point? How do I drop a marker? How do I drop a marker at a specific point? I think we're gonna have to bring up our own map. You know what? Let's just see how close the other one is, right? Oh, that looks really close. I really just have to know now. I just have to know. Okay. Set a work address. No. What I want to do is drop a marker. Can I change that marker? Properties. No. Okay, let's see if we can get this back then. We want 12 044 59674 and 77042 042 6099. Oh, it has to be like dead in the center here, but it's gonna be like an intersection, right? Is that in the middle, or is it that one? It's that one right there, isn't it? Drop a marker here. I wanna drop a marker so bad. Oh, did I get it? Okay. Oh, four, is it this one? Oh, no, I'm moving further away. It's gotta be this one. 043. No, this one. 0459. It's a little bit further down than this one. Is it this one? 046. Is it this one? 04596. 045. I don't know. Is it hard to tell. What's the other one supposed to be? 03? I think. Oh, 37. Am I getting further away? Okay. I need to just figure out how to drop a map on, how to drop a marker on here. Okay. Google Maps. Add marker by latitude, longitude. Okay, let's just do this. Let's go ahead and say, we can come back to this, that didn't take very long. Let's go create a new file. Let's just drop it in here, called map.html. Okay, great. ID equals add marker. Div map canvas. And then what did we want to do exactly? We wanted, yeah, I should have taken these. I want to make it so that in the console, all right, we have a map. And what I want to do is say add marker. Function, map options, map. jQuery.add marker.bind click. Okay, let's just say it like this, which is function add marker lat lon, and then let's just put in here, I don't even really care about this, do I? Not really. Add event listener info window.open. Nope, don't care about that. Marker.setMap. I don't even think we need that. I think that's all we need. Don't need jQuery at all. Okay, and then let's make this lat and lon. And then we don't need jQuery. And then style 100%? Yeah, 100%. That's right. Let's give that a shot. Okay, add marker to map. Let's go ahead and give some attribution. Copy link address. Let's go. Okay. technically, you need a little lang equals en here. Okay, let's go ahead and give this a shot and just load this up and see if this can do this. Now, this is one of my favorite magic tricks. Actually, I'm not even sure we're going to need this. Let's go ahead and pull this up. And then let's go bring up code, cultural development, fast, datasets, Lima. Ooh, this page can't load Google Maps correctly. Do you own this website? For development purposes only. Yeah, that's exactly what I meant. Okay, that's great. I'll take for development purposes only all day. Where is Peru? It's in South America. Man, look at how fast that is. Peru. Lima district. Okay. Now, what I ought to be able to do, and I don't really like that this is scrolling, so I have done something poorly. Let's go with the old F12. Let's close that. What's your problem? You have exceeded the quota. Yeah, whatever. Not super worried about that. Is there in the source for this some sort of, no, just version 3 dot debug? Whatever. Okay, now what I want to do is call my little add function. Go back to the test. Let's go back into here. Go in. And that's really where I want to be. Okay, perfect. And then we just pulled the first edge. Let's go ahead and update that to show us something nice. Finding direction state. And then there was like a 2-string. Let's do, okay. Let's go, let's see here. I want to say var, okay. How about if let's just do this. Location name. $. This dot location name. This dot latitude. This dot longitude. Why is that having trouble? Oh, because you need that. This dot latitude, this dot longitude, and this dot node ID. All right. Now we ought to be able to get this. This is going to be fun. Okay, nodes. Nope, I don't care about nodes. That was a mistake. There's 1.3 million of them, and it's going to try and show me all of them. That was such a mistake. Oh. Okay. Hey, all right, we got nodes. Let's get rid of nodes. We got edges. All right, we got edges. Give me this first edge. Let's plot this. There we go. This ought to be a lot easier now. We can just copy and paste it. Like this. And then what we want to do is say, back to the browser window, add marker. I don't see it. Oh, there it is. Oh, there it is. Let's see where the next one is. Oh man, this is making me so happy. Please be really close. It's just a little street segment. This is perfect. Let's see what the next one is. I'm gonna guess it's like right next to it even more. Like, I bet it's gonna be right here. Oh wait, you know what? The arrows are directly in between the middle. It's gonna be right here. Let's do the next one. And really, all we should need is this. No, we don't want that one. We want this one. We want the even ones. Come on, one time. One time. Now, if I were to guess, there's 800,000 markers, and if we zoomed out and we actually showed 800,000 markers on this map, it would be every single little possible segment of street, because that would be 800,000. The box is about like this. No doubt in my mind it's 800,000 in here. Okay. This makes me feel really good to start. I want an add line. Let's add a line segment. Let's add a line segment. Let's add a line segment. I want a line segment. Take me home tonight. Peru map. Let's say add a line. Add line segment. Lat 1, lawn 1, lat 2, lawn 2. Then what I want to say is, what do I want to say here? I want to just go find how to do that. You get a vote. You get a vote. Add line. Google Maps. Add line segment. Okay. Can I just get drawing a line? A path. What? This is in like a language. Can I just get the JavaScript? Let's go JavaScript. Google Maps. JavaScript. Add line segment. Simple polylines. Shapes. Oh, polyline. There we go. Polyline. This looks like what I want. Add polyline. Oh, look at this. Take me home tonight. Okay, let's do this. I want add line segment. Now what I want is it's a great question. What do I want? Take me home tonight. Yeah, let's just do it like this. Lat 1, lat 2, no, lawn 1, lat 2, lawn 2, just call this line segment. Call this points. We're going to add in a red line with a stroke weight of 2, an opacity of 1, geodesic. Sure. False? I don't know the correct answer here. I'm going to say false. No, I'm just going to leave it as true. They're very short line segments. It shouldn't matter that much. Add line segment. Okay, great. Now what I want to go to is the edge definition, which was in here. And I want to have this edge public override string to string. And then I want to say return $, from dot latitude why is that? Oh, because it's F. From dot latitude from dot longitude to dot latitude to dot longitude. All right, and what this is going to do is give us something that we can copy and paste and put directly into the map. It's going to be so great. Let's just give it a shot real fast. Peru map. I kind of want to just dump out all the edges. I kind of just want to dump out all the edges and see what happens. I don't want a ton of lines. Yeah, no. Is this even the right idea? Yeah, polyline. Yeah, whatever. Okay, let's just keep going. Okay. Now let's go ahead and dump this garbage. Dump it. Run the test. Okay. Edges. And once this comes up, it ought to show us some stuff that'll make this real clean. Oh, that's why it's taking so long. It's actually running the 2-string. Let's go here. Let's refresh this. Where did we figure out that that was? At the big circle. What we want is add line segment. And then we just want to start copying these, basically. Bloop. Points.setMap is not a function. Ah. It's not points, it's line segment. Okay. Try you again. Refresh. Should probably center this on Peru on load. All right, I think it was around here. Oh, no, it was around there. All right, that's our little first line segment. Now let's go ahead and add some more. Add line segment. Where was that one? Oh, look at that. They are not in order at all. That's crazy. Let's just verify for a moment that these are the reverse. Three, 8, 4, 6, 8, and 2, 3, and 6, 6, 2. Yeah, so that's right. Okay, let's go ahead and do 4 then. Oh, add line segment. Must have already had that one. Okay, let's do 6. Oh, there we go. It added a little piece right there. Man, so this is a super, super detailed graph. That's really interesting. Yep, Wow. Okay. All right. So I'm somewhat confident that if we were to actually plot all of these, they would all show up on here. And they would all show up on here. And eventually we would see the whole thing. So what we want to do now is run a search. We just want a starting point and we want a stopping point and we want to run a search. And that's it. And then once we run the search, we want to output the results to some sort of file format that we can then upload into here very easily. That's what we want to do. Let's go ahead and do that. Okay. Okay. We have a giant graph. It's got 800,000 edges. That's not even an incredible amount. If we're doing A star, this should finish in like, hopefully not very long. Let's go ahead and run this. Let's get a starting location. Let's get a stopping location. How are we going to do that? I want to say, give me the closest point from here to here. Okay, so that's what we're going to do. We're going to add a function. We're going to add a function that says, give me the closest point from here to here. Okay, I have a graph. And now what I want to say is some way to get the closest point. Okay. Extract map graph. Let's say instead of this being what's exposed, let's expose, so this will just be private. Doesn't really need to be private. Now what we want to say is give me a problem. Yeah. Public static problem, finding directions problem, extract map problem. And then what we want to say here, since we don't actually know the locations, we're just going to put in a latitude and a longitude twice. We're going to find the closest locations to those latitude and longitudes, and then that's going to be that. Extract. So this is string OSM PBF file name, double lat1, double lon1, double lat2, double lon2. And this is kind of crazy. So let's clean this up a bit. Okay. Now what we want to say is give me the graph. And then this thing, adjacency list weighted graph. So now I have, oh, I got a little question from somebody at work. I have to check in. I am going to pause the stream and I'll be back in a few minutes when I get this sorted out. All right, that turned out not to be anything particularly challenging, just a question I had to answer. So let's go ahead and get back to it here. Let's go ahead and get back to it here. What I want to do is, I think in here we're going to have to actually store the nodes. Do we store the nodes? Yeah, I think we store the nodes. Nope, we don't store the nodes. I think we're going to have to store the nodes so that we can easily get at them. That's probably going to have to happen. We'll come back to that in just a second. The other thing that we could do is, as we run through this, we could just pass back these nodes. Yeah, this is private. Yeah, let's just make this private. And then what we want to do is say graph and then hash set of finding directions problems nodes. Wow, that's kind of ugly right there. Goodness me. And then what we would do here is we would return the graph and we would return the nodes. Oh man. Nodes is a dictionary. Yeah, whatever, just do that. That is really offensive. This is the ugliest function signature I have ever written in my entire life. To do. Make this look like an actual function signature. Alright, then what we want to do is say var graph nodes equals extract map graph, and we want to pass it OSM pb file name. So this is going to give us back this and this. Now what we want to do is say for each var node in nodes. Okay. And what we want to say here is give us the closest one for each var node in nodes. If now we're going to say finding graph state node 1 from 2, and we're going to say if from equals null, then from equals node, 2 equals node. What do you mean? Dot values? Dot values. Seriously? Whatever. Okay. And then what we're going to do is say double distance 1 equals double dot max value, and distance 2 equals double dot max value. Y, yeah, okay, there we go. And then we're going to say distance, I should say distance from, dist 2, dist from equals distance helper dot hover sign of lat1, lon1, and node dot latitude, node dot longitude. Same idea, only this is dist 2. Okay, then what we want to say, and continue. Then what we want to say is var node dist from equals distance helper dot hover sign lat1, lat2, no, lon1, node dot lat, node dot longitude. Okay. And then I want to say node dist 2, then it's if node dist from is less than dist from, then we say dist from equals node dist from, and from equals the closest, which is now node. And then it's the same idea, only this is going to be 2. And we have node dist 2 is less than dist 2. Then dist 2 equals node dist 2, and 2 equals node. And what I want to say is var problem equals new finding directions problem. This one is going to be the graph, which is just graph. And then we need a start, which is from, and 2. Return problem. All right, so the way that this works is we are going to pass in, oh man, what are you giving me hell about? Does not return, oh. There we go. Crap all. Okay, now the way that this works is we pass in the latitude, the longitude, the file name. This is, I should call this from. Lat from, lon from, lat 2, lon 2, lat from, 2, 2, from, 2, 2. Okay, so the way that this works is we pass in the latitude, longitude of the starting place, we pass in the latitude, longitude of the ending place, and then we load up the graph. I'm sure you can click on it as it will update them. Hi, by the way. Hey, what's up, man? Click on it. as it will update them. I'm not entirely sure what you mean there, but yeah, just let me know. So basically, I think I have this set up now where we have grabbed a map of the entirety of Lima, Peru, the var when you rename. Oh, wait, so if I just rename from like to this, and then I can just click on this. Wait, click on this. I'm sure you can click on it as it will update them. Oh, here it is. Is that the one you mean? Bloop. Okay, that makes sense. That's cool. I did not know that. Is there a way to do all of them? That do all of them and I wasn't paying attention? Update. No, it did not. Okay, well that's cool still. That's definitely something that is nice to know. There probably is. I'm not going to worry about it at this exact moment because I am so close to being able to search through the entirety of Lima, Peru. Okay, so let me just show you what we've got here since you're here, because you'll like this. We have a map of Lima, Peru that's like this size, essentially. It's like all of that area right there. And what we're going to see is that it turns out that there are a lot of points in here. If we zoom in, look at all these little streets. I'm not sure if you can see those, but there's tons and tons and tons of streets all over the place, right? All over the place, just streets everywhere. Little towns, little cities, little everything. And according to the map that we extracted, there are about 900,000 or so, 850, 900,000 little line segments. And I plotted a few of them right here. So you can get an idea of about how long each of these line segments are. And there's about 800,000 of them that make up all of the streets throughout this entire spot. And what I have done is create a function where you can basically just say like, okay, boom, I want to start right here and I want to end right here. Ooh, clicking is a good idea. What if we clicked and it told you the location? Oh, that would be so easy. That would make this so much more fun. But anyway, the idea is that we should now be able to search, and when it spits out the output, we should then be able to graph all of the points and show the actual optimal path from one location to another. And I've got about 45 minutes, and that's my goal, is to get to that point. So let's make it so that when you click, it tells you the latitude, longitude. That's what I want to do. So I can come in and I can be like, boom, right here. I'm right here. And it's just like, okay, show me the latitude, longitude of that. All right, how do we do that? Google Maps, JavaScript, get lat long on click. There we go. I like that one. Let's go ahead and pop that in here. Add listener. I don't want to alert this. I want to console.log it. And I want to console.log it in a way that will let me easily copy and paste it to put it somewhere else. So I think what we're going to do is just say parentheses, comma. Oh, it's already got a comma. I wish it wouldn't do that. Comma. And then plus closing parentheses. So this should give us the lat long when we click. And that's what we're going to use as the input. I don't even need these. Oh, I do need that because it's JavaScript and you need to coerce it to a string first. Okay. That's great. That should give it the ability to, how do I copy, share, copy link address, give a little attribution. Great. I also need to add the attribution for that line segment one. Oh no, I lost it. Oops. I am sure. Oh, there it is right there. Give that attribution. Okay. Don't need that anymore. Don't need that anymore. Want to reload. Yes. Thank you for complaining. Uncaught error, cannot read property E3 of undefined of object.addListener. I think maybe what I wanted to do was actually not put this here, but instead put it in the thing that actually creates the initialize. There we go. Make sure we actually have a map before we try to do that. Oh, I'm really confused now. What's going on? There we go. Let's see if that works. Reload. Okay, great. Feels like it's trying to load that API twice. Anyway, Lima. Why did we choose Lima? It was a fairly decent sized city without being too big. We're going to start right here. Pop. Oh, look at that. And we're going to end right in the heart of the city at this big roundabout thing. Pop. Right there. Okay, so that's our starting location and our ending location. And let's go ahead and see if we can run a test that'll give us the results. We want to test. We have now extracted the map graph. That's not what we want. We want extract map problem. And we want to pass it in our locations from let's go ahead and drop this down. And 2. I'm really excited about this at the moment. I'm not sure if that's coming through appropriately. Okay, we now have a problem. Let's solve the problem. We need a solver. Solver test. Oh, no, let's see if this works. First of all, how are we going to test this? Lima dot get initial state. I don't know how to test this other than it doesn't throw an error. Is there a way to test that? I don't really know. Let's just run this test and see if it works. Should take a hot minute because it's loading it up. Oh, it failed because it did throw an error. Adjacency list weighted graph. Extract map graph. Had I never gotten to the point where I had actually done that? What's the problem? An item with the same key has already been added. Okay, debug time. Let's go to debugging. Nothing like a little bug to slow down your motivation and excitement. Adjacency list, weighted graph, to dictionary. So I have to remove duplicate edges. Oh, that's really frustrating. Why would I have duplicate edges? Multiple ways have the same edges in them? I believe that. Okay, multiple ways have the same edges in them. So what I need to do is dedupe the edges. Goodness me, how am I going to dedupe the edges? How am I going to dedupe the edges? I guess I could just group by here. Let's do that. I really don't want this logic in here. I'm going to do this for now as like a hack so that I can move on. But we're going to put this in here. Remove this logic. Deduping edges should happen. Should throw. M.group by. M dot no, not M. J dot to dot node ID dot to dictionary. Only on this to dictionary, what I want to do is say key, and then I want to say J dot select, no, dot order by T dot weight. This will order them by min, and then I want to say give me the first, and I need to create a tuple. Yep. Var. This is awful. A equals first return a dot to a dot weight semicolon bracket. Okay, that's really bad. Revert this. Definitely don't want to stick with that. But this will take care of the deduping problem by giving us the edge that has the smallest weight and assuming that is the only one that matters. Okay, let's try this one more time. Okay, and that time it passed. That's great. Now let's go to the finding directions solver test. And let's go with solve Lima. I don't want to do a breadth first search. That will actually be slow, so we are going to have to come up with a heuristic, which is not going to be particularly difficult. We just need to do it. Let's go with the not Romania problem. We're going to go with IDA star because I think it's going to be the fastest. And we're just going to create that down here. IDA star, not Romania. We're going to call this Lima straight line distance heuristic. And the way that we're going to create this heuristic is it's going to be, it needs to take in Oh, it needs the goal. Oh, I need to be able to get the goal. Okay. Okay, let's create the problem first. We want OpenStreetMap. We want open helpers dot OpenStreetMap helper dot extract map problem, and we want to give it the location. Basically, we want to copy this. Finding directions, solvers. Let's just put this up here. This is going to be Lima problem. We'll just call it problem. And we'll just call this file name. I want this to be a little abstract so that it's really easy to copy and paste. Let's add this in using fast.helpers. Okay, now we have a problem. Now what I want to do is get the goal from the problem. So we're going to have to go change the goal. And this is going to be iProblem. Which I did not put in a file called iProblem, which is awesome because it makes it so easy to find. There we go. And we want tstate get goal state. That's what we want right there. And then we want to re-implement this. And then what we want to do is have this be get initial state. And then we want public in puzzle get goal state, and this is going to be return in puzzle. We're gonna have to is goal this dot goal. I guess we should just have like a generic one here. Yeah, I did such a bad job of writing this in puzzle state and then abstracting it away later. Just such a horrible job. Let's just say call this generate goal state is going to be public. There we go. See how I did that? And then I'm going to say in puzzle dot generate goal state of this dot rows in rows this dot in calls. Oh man, not in puzzle. U long. Okay. Var goal internal representation equals that, and then return new in puzzle oh, I guess I can just do that. Yeah, I can just do that. Return new in puzzle, because if you just create it and you don't specify a starting, then it gives you just the goal state. Then we need to solve it for this one. I can close that. I should start closing a bunch of this garbage. Ooh, don't close that. To from. I feel good about that. I feel good about that. I don't like that, but I feel okay about it. Finding directions. Goal state. This one will be really easy because it's just specified. So we can just say public finding direction state get goal state is end. Just return end. Okay, great. Now I can get the goal state. Yep. Now let's go back and fix this. Var goal equals problem.getGoalState. Now what we want to do is say heuristic is from to, and these need to be finding directions state from finding directions state to, and this needs to be distance helper dot Havershine of from dot latitude from dot longitude to dot latitude to dot longitude. Oh, I really thought that was going to help, but you can't do it this way. You have to do this as a func. Oh, yeah, that's the other thing. It needs to just take in one from. It just needs to take in a from. Func. Yep, okay. From heuristic is from I think we're still going to put that on the next line. And then it's not from to, it's goal. Why are you still giving me hell? Var finding direction state. Funcs return values. Double. Yes. We now have a heuristic that'll tell us the straight line distance between any 2 points. Yes, we do. Now we have a problem. Now we have a solver. Now we want to solve it. I think test solver is a good choice here. I have no idea what the real distance is supposed to be. Not one bit. Would take an enormous amount of time to solve that by hand. But I figure if we run it the first time, we can just assume that it's correct. And really what we're trying to do is test the time. And what we want to do this time is we actually want to print out each of the intermediate states. Yes, we do. Why do we want to do that? Because that is the actual goal. Okay, let's do that then. Let's do that. Let's go finding directions, solver test, test solver. And on this, we want to write out each of the goals. State.toString. State is output dot toString. Output dot write line of state dot toString. I'm really hoping this does it. I really just want to see this work one time. If this works, all right, there's only 800,000 states. It ought to do this pretty quickly. No, there's fewer than that. No, there's one. There was only so many edges, and the edges are the ones that matter. Yeah, there's only so many edges. There were 800,000 edges, and we know that some of them, well, it was about 900,000 actually, and some of them were duplicated. So hopefully it removed a few of them. And then the ideal here is we would like to see a result in a few seconds. I'm going to say a few seconds after it finishes loading, of course. We know that just loading up all of the data takes 5 seconds or something like that. 6 seconds seems to take about 6 seconds. 7 seconds, 6.5 seconds. So 6.5 seconds to load. I'm gonna guess about 4 or 5 seconds to do the search, and then that's gonna be it. Hopefully. How do we run this? Just run it. Let's see what happens. Two, 3, 4, 5. Evals 2. No solution, but one should exist. Interesting. Interesting. Interesting, interesting, interesting. Whew. There is no crazy world where this is correct. Maybe the idea is I have to collect anything that has highway on it. I don't know. Okay. Okay. Because these two things did not find a path, it means that we do not have edges connecting all of the points, which is fine. How do we go about getting all of the edges that we need to connect the points? The only thing that is coming to mind is grabbing all of the roads, all of the highways, and not limiting it to just these big ones, because maybe I'm not getting the correct type. I think also maybe what we ought to do is choose a smaller area first, instead of having something that's so far away, like center of the city all the way to out here. Let's choose something that's like right here to something that's like right here. Let's try this first. Okay. And to here. And if these two are not connected, then yeah, I've got some sort of serious problem, probably with the way that I'm extracting the data. I'm not entirely sure that a Google map would be able to handle dumping out all of the line segments that I have, but maybe we just try it. I don't even know how big that file would be. That's the real problem. It's like it would be megabytes that it was loading up, and then trying to display all of this crap on a map. I don't know. Let's see what we can come up with. I should put these next to each other. Oops. Okay. Let's try this one more time. It was cool though how fast it found that there was no location, which means that, look, evals 2. Oh, you know what? I'm not limiting this to nodes that are in my edge list when I'm doing the find closest. So that is what I need to do. Yep. There was 1.35 million nodes, but I only had 800,000 edges, and it's possible that a lot of those nodes were not on the roads. I think that's the problem. Let's go ahead and change the way that we extract this so that the nodes at the end isn't just this. We're going to say var graph nodes equal graph crap. Okay. Hash set. Okay, we can do this. Var graph nodes equal new hash set of finding direction state. Graph nodes is what I want to return instead. Come on. Graph nodes. Now when I go to here, I want to say graph nodes dot add a graph nodes dot add b. And because this is a set, it will dedupe them for us. And then we return those. Now we need to fix this up here to just be like that. Now what it should do is it should find the closest point that is in one of our edges. That's why it was failing so quickly, because it was saying, oh my goodness, I have no edges connected to this thing, and therefore I am not exploring anywhere else. That's the trigger that like pointed me in this direction. Okay, let's go ahead and take a look at this one more time. And let's cross our fingers. I wish it didn't take so long to load it up, but at the same time, like, it is what it is. If we ever got to like a bigger map, I'm not sure. Like if we had to wait every time we wanted to run a test, if we had to wait like minutes, that would be awful. I feel confident that it's gotten past 6 seconds now. And it should be dumping out some results. It has searched through 67 million, my goodness. This is total cost in miles. So I guess one thing that we could do is we could go and grab the total distance in miles. We're gonna have to do some bounding here. Like, you see how small of an increase this is making? Let's go ahead and just see how far the real distance is. And then we can estimate how long this is going to take. Maps.google.com. And then we want directions. And we want directions to here. No known directions. I should really pull when I run this. I should really pull the locations that it's choosing. Do we remember where we clicked? I know one way that we can find out. We can say add marker of this second location. That's where we clicked. Okay, so what's around here? A bunch of yellow stuff, Lima District, and the road that we want is Avenue 28 and just above Avenue 28. Okay, just above Avenue 28. I don't see an Avenue 28. El Agostino Corporation. El Agostino Corporation. There it is, right here. Here it is. Which one did we want to do? Come around a little jot up. A little jot up. I want to say it's right here. 8.2 kilometers. Oh man, come on. It's like nothing's easy. 8.2 kilometers in miles. Yeah, in miles. 5.095. All right, so this is going to have to crawl its way all the way up to 5.09. Okay, so iterative deepening on a map like this, where you have such small little improvements, not a good idea. Let's go ahead and kill this. And then let's just run regular old A star, not iterative deepening. Even though it's exploring a ridiculous number of states per second, like there really should only be about this many total. So I'm thinking that A star is going to work just fine. Let's go ahead and kill this task manager. Let's kill this. Okay, that's iterative deepening. Hooray, that was fun, but not fun. Oh goodness me. Oh goodness me. Delete all of these. Okay. Instead of running iterative deepening A star, let's just run A star. Try this one more time. Okay. Is it running? Look! It seems to think that the distance was only this far. Let's go ahead and let's pull this out. And let's plot all of these. Right here. Let's clean this up. Give me Sublime Text. Do a little magic here. Did you see how fast that was? How fast was that actual test? 95 milliseconds? That's not bad. 95 milliseconds. For just using straight line distance, that is so not bad. Okay, what I want to do is clean this up. This is going to be... and what do I need it to look like? Finding directions? No, I need my Peru map. And then what I want to say is add line segment. I need a way to Add results. Need a way to add results easily. So I'm going to say add results. Show results segment. We're not going to need anything here. And then what we're going to need here is this to be replaced. Let's give an example. And then let's come over here. And we want to say this, maybe one of those. Now we want to be in an actual group. Maybe one of those, /d plus dot, maybe dot, I'm going to say there's going to be a dot, d plus, comma, space, minus maybe, dot, d plus, dot, d plus, closing, comma, and then some garbage, dot star. All right, now what we want to do is we want to replace this with lat :1 lon :2 close bracket comma replace all. That appears to have worked. Control A, Control C. I'll take it. Looks like garbage, but I'll take it. I'm so excited. I can't wait to plug this in. Show results segment. I wonder if these are ordered. Yeah, they are ordered in the right way. Let's give this, yeah, red's cool. Let's stick with red. Let's load this up. I don't need this anymore. I need this. You give me some hell, and I say show results segment. Oh! Long, not a number, because I called it the wrong thing. Control H. Lon to LNG. No, just LNG, not O. How did I even type that O? That's really crazy. Control A, Control C. Control V. Not even going to worry about. Okay. Come on, one time. Show results segment, please. Oh, man. Oh, man. Look, it actually follows the road. It actually follows the road. It even goes around the turn. Woo! Okay, what is this garbage? Something got busted. I am pretty happy with the way that all this worked out so far. I would love to just like write a little web API real fast that like you can call it with any 2 points that you click, and then boom, it just gives you the directions. Oh man, I'm just having such a good time with this. I am just having such a good time. What are these errors about? Let's go ahead and just see if we can clean up any error. Oh man, of course you're gonna look like that. Maps type error, cannot read property C of undefined. cannot read property C. I don't even know what that means. Okay. Let's just go. Google Maps. Of undefined. And it gave me 7 of these. I'm not entirely sure why it did that. Let's see, am I missing something here? What is the difference between these two lines? JS v3 sensor true. Google APIs. Oh, it's the script thing. That can't be. It wasn't giving me any errors like that. It's doing this only after I call this function. Lat lon. I'm not entirely sure what's going on here. Maybe it's this comma. Maybe it thinks some of these are undefined. I don't see any of these being undefined. Nope. Yeah, I don't know. How about this add marker thing? I don't need that, huh? There you go. Don't need add marker. Line segment, path, points. Yep. Geodesic, whatever. Okay, you know what? Not going to worry about it. I am super thrilled at this. That's too much fun. That is too much fun. Actually writing something that finds the shortest directions on a map. Let's do a longer one. Wait, hold on. Let's do a longer one. Right? Let's do a longer one. Finding directions. Solver. Let's do these. All right, this one's going to be a lot longer. And then let's go ahead and plot these. We'll kick this off, and then we're going to go ahead and plot these and get directions. And then the idea being we'll compare ours to what Google Maps actually says. So let's go from here. Why is it not recording this when I press the copy button? Copy. It's like not recording it to the... Okay. And then let's go to... What am I trying to go to? I'm trying to go to here. See what you say. Okay, this is going to be a fun one. Let's see. Do you want to give me the same idea? I feel really good about this. That's fun. So this one, the one that I'm doing is looking for straight up shortest distance. So it'll take whatever little shortcut it can possibly find. It's not going to consider, and mine also isn't going to consider one-way streets, which might be an issue around here. Like why it didn't choose. See how this is a one-way street? And why mine might choose this one? Because it's a shorter path. So I don't expect mine to be the exact same, but I expect it to be pretty close. Let's see if it finished. Oh, it finished. Oh, it finished. And it found all 9 miles. How long did this take? 71 milliseconds. Not long at all. Same idea. Let's copy it. 283 segments. I'm liking this. Control V. Control H. Do this crazy one. Do this crazy one, but change this to be the correct thing. Do a little replace all. Do a little copy all. Do a little Peru map. Do a little pasting. Do a little saving. Do a little reloading. Oops. Do a little reloading. Do a little zooming. Do a little scrolling. Do a little zooming. Come on, one time. Ooh! 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 Okay. Yeah, again, do notice that mine did not exactly choose the correct direction on the one-way street, so I think that's like I put a to-do in there to sort that out. Oh man. That is so great. That is so great. We can find directions all over the city of Peru in under 100 milliseconds. That is so great. That is so great. Okay, I'm gonna wrap this up. It's right at 2 o'clock. Man, I feel great about this. We made a lot of progress today. We actually got this thing to solve on a real map. There's a lot of bugginess and little things about it, but I do think that one of the things that we can do is sort that out tomorrow, maybe, or maybe this weekend, or if somebody wants to do a pull request and sort out the one-way street. The way that you do it is when you're inspecting the tags, there is an identifier in the tags for one way, which you can find more about if you go in here. It's like one way right here. And if you, oh look, it also has max speed. Ooh, there's all kinds of crazy stuff you can do. Max speed. Then we could actually have like, we can say like, this is how far you have to go, and here's the maximum speed you're allowed to go. Oh, sorry, man. Messing up's not fun. Well, I hope you didn't mess anything up too bad, but, if there's anything I can do, let me know. I'll be more than happy to help if I can in any way. No idea what you messed up, just, All right. Yeah, if anybody wants to submit a pull request, just take into account this one-way thing to essentially in here, when we are extracting the nodes, take into account one way and only add the correct direction. Don't think so. Okay, well, I'm glad to hear that. Smiley faces are better. So, feel good about that. Yeah. And it's Valentine's Day. So how bad can it be? And that's it. I think tomorrow I want to clean a bunch of this stuff up, and I want to get a little UI working where you just click twice on the map and it fires it off in the background, a little request, and it just sends you back the results. And then it plots them. And it's like, hey, I have plotted them. Because that just sounds like so much fun. This would be a nice little thing. I think after this, I'm going to write a nice blog post. Be like, hey, here is an example of doing a real search on Lima, and then maybe we can ramp this up to an even bigger data set. And see, I bet it craps out once we get bigger. This isn't really that big. This is only like 1 million nodes. What if we had 1 billion? What if we had 10 million? Maybe we'll go to 10 million next, then we'll go to 100, then we'll go to 1 billion. It's a pretty big steps each time. All right, I got to get going. Thanks for joining, everybody. I had a blast today, and I'll see you tomorrow. And we're going to have some more fun. Man, this is awesome. Thanks again.